Good morning, good afternoon, and good evening, because I know that you are coming from different corners of the earth, far from East in Japan until here in Europe, from London. Welcome, everybody. My name is Timon, and I'm super happy to be the host of today's Startup School Agentic AI session. Today, we're finally getting into it, and we're finally getting into Agent Development Kit, also abbreviated as ADK, but we're also going to talk about LangChain and MCPs and more and more and more. Really practical knowledge today. Grab a coffee. Once I'm having a coffee here, and I'm going to explain a few rules and housekeeping rules over here, but we're going to get into it in just a minute or two. So for those of you who are with us for the some time already, you know the drill, you know the next couple of slides, they are the same, but just a reminder that we are in week 2. We are right now unlocking agent potential. We had a fantastic week 1 and week 0, but still a lot of ahead of us in week 3, also where we're going to have the guest speakers from the Datadog. But please bear with us, and please join us on next Tuesday, Wednesday, and Thursday as well. Just a quick reminder, I feel that the last session on Tuesday I explained very well all the situation with the notebooks and labs, but just for your information, we are having this live. This is possible to watch on demand, and we recommend to do some labs and notebooks and code labs. And the whole list is under this short link over there, Google/Agentic AI-Labs. It is not case sensitive right now. You can put also Agentic AI Labs with the smaller letters. It's going to work. One addition, there is like a last update line. So make sure that you see that the last update is on June 19th. If not, please do refresh your cache and memory and cookies, or open it in an incognito window. It should download the most up-to-date PDF. I'm also was informed that the situation with the few notebooks that were not working should be better, but just bear with us and try again if they're not working as intended. But please take use of these labs. This is a fantastic way to, in practice, see how all those elements are working together. Skills boost. Some of those labs need credits. There are special credits for the labs because labs are creating the temporary environment with the full power of Google Cloud Platform. That's why we want to give you all 200 credits so that you can play and finish as many labs actually as you can. With 200 credits, you're really good. You're really set up. You all received emails from Google Cloud at google.com with either confirmation or reminder where we send those instructions. You have a unique URL over there that you need to click in an incognito window and then redeem the codes. I think that, and I saw that many of you already did that, but just in case, here are the instructions. And in case of any troubles, please shoot us an email at startupschool-external@google.com. We received some of those emails from you already, and we've helped all of you. So you should be good to go. For the end part, just a few housekeeping rules. I love when I see the engagement in the Q&A section down below my face. Do not skip and go to the YouTube because you're going to lose the chat and you're going to lose the Q&A part. And this is where we try to answer your questions as soon as possible. We're going to ask a few of those questions to our today's speaker, today's instructor at the end. This will be recorded, so you can come back anytime to this on this very site that you are right now. Just the one difference is that this video will be available on demand in the evening, my evening on June 19th, so in like 7-8 hours. We're not sharing the slides, but as I said, the video is up there and the quick labs are for you at no cost, so because you get credits. We sometimes also recommend code labs or notebooks, but then you need your Jupyter notebook to run those, but I'm sure you're familiar how it looks like. Please do not try to do the labs and notebooks right now where we try to do them in your free time when you have time as a kind of a homework. It's a school, so let's call it a homework. Okay, enough with the housekeeping. That was fast. That was much faster than last week, which I'm happy because I have a fantastic speaker to invite to our stage. Christos is going to today be with us. He's a machine learning architect, a fantastic Gen AI specialist. Christos, are you there with us? And here you are. Calling from our sunny, I see a sunny London, right? It's not a very obvious thing to notice in London, but I see you have some sun over there.
Yeah, the weather is super hot today. Hello, everyone. So I'm Christos Aniftos. I am a machine learning solutions architect specializing in generative AI, and I've been looking to agents for the last maybe 2 years. By now. Today we'll be covering a lot of things. You see them on the screen. We'll talk about the agentic landscape. We will talk about ADK, Google's framework for building generative AI agents. We'll talk about deploying those agents and evaluating them. And then you will have the chance to ask many questions at the end of this session. So I've done my intro, so skipping to this slide here. So what is an agent? And at the very high level, it's AI systems that can reason, they can take actions, and they can use tools to complete a task or a goal. And it's more than a Q&A, it's more than a traditional React implementation. So they have a role and they have a goal. So an agent might be a data scientist agent with a goal of creating a chart or analyzing a data set to predict, let's say, the weather. They can reason. They can decide how to execute that goal, and they have the freedom to select different tools and different, let's say, execution steps to get to that solution. And they can use tools to connect to the world. So they can use APIs, they can execute code, they can connect to databases. And of course, you couldn't have an agent without memory, right? You couldn't have an agent that forgets what happened in the previous step or what the user asked. So the ability to have the concept of memory and session and maintain that memory through the execution of a task or through a conversation is very critical. So taking this one level deeper, we have a model. An agent has a model, and that is the brain of the agent, and that's your LLM model in the background. So that is used to have natural language understanding, do the reasoning and decision making. Then we have the tools. So the tools are how we connect to the outside world, databases, connectivity, APIs. We'll talk about MCP, or a tool might be triggering another agent. Then we have the orchestration of the execution flows, the logic, and that's kind of the workflow engine that keeps everything moving forwards, decides what to do next, when to call the model, when to execute some code, use the tools, when to save something into memory. And then it's your runtime, where is the place where you run your agent, and the runtimes. They do come with state management, handles retries, logs, and provides tracing to the developers. Okay, so one agent is powerful, but what happens when you have to build systems that are complex, right? So this is where you get into multi-agent architectures. So there are different characteristics for this architecture. So the one is the modularity. So the fact that you can break a complex task that otherwise you could have a jumbo, big, massive agent taking care of it into smaller problems. And with that, you can create specialization. So you can have specialized agents that they can handle different parts of these complex, let's say, systems. So you can have a data scientist agent, you can have a researcher agent, you can have an agent that can write and execute code. And by that, you split the responsibilities into these different agents, which they are focused into solving one task. And by the way, creating specialized agents, it's easier because you can split your prompts, the instructions to be more focused on a task. as opposed to have an agent that can change roles, during the execution. Then you get these agents to collaborate. So, and as you see here in the diagram, you might have like different agents that they can talk to each other, and they can complete tasks and say, okay, now it's over to you. You might have an agent that it's data crunching and brings data from a database and then hands the data over to the data scientist to perform an operation. And with this way, you can have scalability. So each agent, it's easier to update, debug, like figure out if there's something wrong. You can test each agent individually before you integrate them into a bigger system. And of course, you can scale each agent individually. So, and this is how we transit from having agents that they perform simple tasks into complex workflows that require different expertise to achieve the end goal. So, when do we need agents? And this is super important. So you don't jump into agents, automatically without thinking like what's a possible implementations, or what is the alternatives or simpler solutions to get to your goal. So first, if you need a real world integration, we talk about tools. So if the flow is not just calling an LLM to get an answer from its internal knowledge without using any tools, then you might need an agent. So if it's an LLM and calling an API, then an agent might be the solution. The second area to look at is if multiple steps are involved. So for example, to achieve my goal, I need to take multiple steps to do that. It's not just a single turn. It's not just asking the LLM and getting back response, but it might be asking the LLM is thinking, deciding what tool to use, getting the answer from this tool, sending it back to the LLM to turn the answer of a tool, which might be a JSON, into a natural language format, and then return that to the user. So multiple steps is also something to, a decision criteria for building agents. And then it's the execution path. So if the execution path is not predictable, is not, let's say, fixed, then you might need an agent to make the decision on how to run the execution. And what we mean by that is sometimes based on the question that the user asks the agent, or the instruction to the agent might decide to use a BigQuery table to bring data, or it might decide to use, let's say, the weather API to bring data. So, and this decision is made on the fly. It's not pre-scripted into the flow, but it's up to the agent to decide, well, the question of the user is about weather, go to the weather API. If the question of the user is about, let's say, the city demographics, go to the BigQuery and bring that data back. So you let the agent to make this decision. And finally is this adaptation basically that the agent allows you to do. On your screen, you see 3 example use cases that an agent might be beneficial. So a study tool that learns from the user, behavior and data and adapts over time. Maybe a refund system that makes a decision when to issue a refund automatically or when to escalate to a human, and so on. Then you might have a factory maintenance scheduler which reacts in real time based on the signals that are processed. So just kind of to wrap up, think of when you need to think, decide, and act, and every time the process or the workflow changes, is not fixed, then an agent can be very beneficial. Having said that, by the way, it doesn't mean that if your workflow is fixed, you cannot use an agent. You can still use agents for that as well, and guide the agent into performing very specific steps one after the other. But in that case, an alternatives might also be used. It doesn't have to be an agentic system. So when you don't have to use an agent, or maybe when you don't want to use an agent, are examples where they're like single turns, stateless, you don't need to use memory, and the flow is predictable. So if you have a prompt, for example, that generates a marketing copy based on an input you give it, this is a single turn, you might get a very good marketing copy. And if that already works really well, you don't need to do that multiple iterations or refine it and so on, then you keep it as is. It's just an LLM with an instruction, you get back a good marketing copy to use. Another approach is when you have your traditional Q&A systems that they use React. That they use RAG in order to retrieve data. So in that case, you just need the LLM. It's grounded with a RAG architecture to retrieve and hydrate your prompt, and then it gives you back a response. Again, it's pretty straightforward. You ask a question, finds similarities on your knowledge base, hydrates the prompt, and then gives you back a response. And another reason why you might avoid using agents is when you work with very heavily regulated industries, and you have something that's already working really well, like a classifier, and you don't want to kind of change that. If you're already happy with what you have, and you're afraid that regulators might question a lot your implementation. You might want to kind of rethink about it or talk to the regulators before you jump into building or replacing your solution with agents. Right, so we have different levels of abstraction. At the very kind of base level 0, we have the do-it-yourself. What do-it-yourself means here is that you have the LLM, or you connect to an LLM large language model API directly, and it's up to you to build that agent. And this is not easy, because if you think about it, if I just have this LLM call, I need to figure out how I manage memory, the session, the state. How do I have this multi-turn conversation with the LLM, which is not, you don't get it out of the box by using the API. You just have a single turn to the API, and then you have to somehow organize your prompts, maintain your prompt templates with containing history, and how you execute tools, how you get the tool responses, sending them back to the API to form a response. So it's super flexible because you're at the very low level, but it's like for me as a developer, I will call this unmanageable. It's really hard to build agents by doing it this way. You're better off building a framework or using a framework that already exists. Then we go one level higher, which is the low-level LLM frameworks like LangChain, which gives you some some tools out of the box. You can start building flows. You can deal with retaining some memory. It gives you some kind of React loops that can help you with the thinking process. But still, we're not there. We're still at the very low level. We can build chains, but that's not really agents. You have to, again, do a lot of work on top to glue all these pieces together. And then we have LangGraph, a very popular framework to build agentic flows. But with LangGraph, you can define agents as nodes, and you have to start thinking of nodes and edges and how you connect those together to build those reasoning paths. And it's not like the effort that you have at level 0 and 1, we are at a very good spot when we use LangGraph to build our agentic workflows, right? But the key element here is that you need to think of nodes and edges and how you connect them together. And then we have another layer of abstraction, which is level 3. So this is the agent development kit, or the OpenAI Agents SDK, which allows you to focus on defining your agents, giving your agents instructions, creating tools, and the frameworks will manage the execution flow. So they have components like tools, memory, session state, and orchestration. And you don't need to worry too much about nodes and edges and how you connect them together. You just pass that burden up to the agent to decide how to execute a task. And of course, you can guide that agent by prompting and giving some instructions in the prompt, but not by coding the connection of these nodes and edges. And then we have the node code platforms, which is for quick prototyping or non-technical teams that they don't want to go into code. Some use cases, they might be good enough to use with no-code platforms. But at the end of the day, the takeaway here is that, the higher you go, you trade off with flexibility. So you have less flexibility, but you speed up development. And it's up to you and your use case to decide what level of abstraction you need. In my point of view, you start from the highest level because that's the easiest to use, and then you go down if that high level of abstraction is not suitable for your use case. Okay, so let's look into ADK. So what is ADK? ADK stands for Agent Development Kit, and it's a flexible and modular framework for developing and deploying AI agents. This is a framework developed by Google, and you can use ADK not only with Google's models, so not only with Gemini, but with other popular LLMs and open source generative AI tools. And having said that, with ADK, you can also use LangChain tools because ADK provides a wrapper. So you can take a LangChain tool and put it into ADK, or you can take CrewAI tools and put it into ADK, which is super cool because you can reuse the tools that are already available out there. And it also, one of the benefits, even though you can use ADK with other models and so on, because it's a Google created framework, it integrates really, really well with the Google ecosystem and the Gemini models. So you get live streaming out of the box, bidirectional streaming, which we believe that's a super helpful and a very good reason why someone might want to use ADK with our Gemini models. So we'll look into a few concepts of ADK, and I will be showing code as well. So I'll be going back and forth, sharing my screen, sharing some of, like the concepts, and then showing you in code how those are implemented and what they do in practice. So let's talk about the conversational context. So there are three things here to look at. I would call it 3.5. There is one more that is missing from here, which is artifacts, but I will be talking about artifacts in a couple of slides. So in a conversation with an agent, you have a session. And within the session, you have a state. The state is variables you store. In addition to that, you have a long-term memory. So I won't give you more details about that because I have individual slides for each one. So here you see a session. So a session corresponds to a current conversation thread, and it stores the history of the interactions between the user and the agentic system. It's not just the user and the agent, it stores all the events that are happening on the agent side, which might be called to an LLM, called to a tool with what parameters, the response from that tool, and it keeps all this information, the history, in a chronological order. And because this session is maintained through the conversation, the agent knows what happened before and therefore can do better decisions on what to do next. This is showing a very simple example on how you define a session. So you create the session and then you put the session in the runner, which is how we can run an agent. Again, this is a very small snapshot of the code. You will see the full definition of how we define an agent, the runner, the session, and how we can interact with this agent. So there are 3 different types of sessions. So you have the in-memory service, which allows you to store all session data directly into the application memory. And this is non-persistent. So which means if you restart your application, all these sessions will be lost. So a way to think about it is that this is a very good implementation for quick development. So when you're prototyping on your local computer or on a VM, you want to use in-memory session service because you want to quickly prototype. You don't care if you restart and you lose that conversation. You can start the conversation again. So it's very good for local testing, doing POCs, quick development. In order to have more persistent session, which would allow a user to resume a conversation, let's say that you're using Gemini on your mobile phone. If you go to Gemini, you will see your previous conversations and you can resume those conversations. So this is because that is using a persistent memory. So it's not using an in-memory session service. Then therefore it saves all the conversations and you can resume them. So there are 2 different ways to implement persistent session. The one is by defining your own database for your session service. So you can define it as MySQL, SQLite, Postgres, and so on. And that stores session data into tables. Let's say the trade-off there is that you need to set up this database yourselves. Alternatively, you can benefit from our session service, which we provide on Vertex AI, which is a session management service that it's triggered using an API, and it's managed. So you don't need to set up a database yourself. You just use this service and you're good to go. And we'll talk about Agent Engine later on, which uses this service by default in the background. So state is living within the session. And that's one of the, let's say, components the agent has to make, let's say, keep some information. So we think of it as kind of the session's scratchpad. So we can save variables in a key value format. And those variables can then be retrieved by tools, by other agents. So a way to, let me give you a practical example. So let's say you have we talked before about the data extraction agent. So the job of this agent is to retrieve data from a database. What this agent can do is it can pull the data from a database, turn them into a nice dictionary, and save the data into the state. Then we have a data scientist agent that is coming next. It was triggered after the data retrieval agent. The data scientist agent can go into state and find that dictionary because it was saved there, load it, and continue the data science operations. So load them into pandas and do some analysis. So state is really good to provide information to agents, maybe the name of the user, the profile of the user, and so on. And we have there a node, so avoid saving complex objects to the state. The recommendation there is that you save dictionaries, or if you have objects, see how you can turn these objects into a dictionary. Like you can turn them into, serialize them into a dictionary, and then the next agent can take that dictionary and load it back into, into memory. Okay, so here we see how the state is implemented. Let's say you have some key value pairs like customer information and current date, and we load that into our session state memory. So this state, by the way, it can be something that you load at the beginning of a conversation. So it's something that it's at the startup of the conversation, or you can create this state dynamically through the interactions between the user and the agent. And how an agent can access state information, or one of the ways that an agent can access the state information, is by using the key of the state as a, let's say, placeholder inside the prompt. So when this prompt is going to be materialized, when the agent is called, it will replace customer information with this dictionary here, which calls the name of the user, and the current date with the current date. Okay, so now let's jump into memory. And memory is different than session, because session is focused on a very specific conversation that you're having, like a new chat you're having with the agent, whereas memory is knowledge that is across chats. The memory stores information in the application memory. Scratch that. So what I want to say is that there are two types of memories, and think of the memory as kind of a rack corpus, which the agent can go and retrieve information based on what the user is asking the agent. And we have two types of implementations. We have an in-memory memory service, which everything is stored again in the laptop or the VM that you're prototyping. Doesn't make sense to use an in-memory long-term memory service, because the two are they're conflicting. So to have a long-term memory, you want a persistent way to store this knowledge. So the in-memory is truly only for prototyping. For long-term kind of storage of this knowledge, you can use Vertex AI RAC memory service, which we provide integration within ADK. And what happens is that you can save sessions, specific sessions in memory, or other kind of knowledge within that memory, and then agent can retrieve that knowledge so it can better answer the questions. And this is how you define this memory. So essentially, this comes from Vertex AI. It's when you create a RAC corpora, and you have this corpus ID, you replace that ID with your own corpus ID. And then you have some parameters on how this RAG engine or service behaves. So how many matches to retrieve, and the distance, the vector distance. And you define the memory service as such, right? And then you pass that to the runner. Now, the last thing that has to do with managing information, saving and retrieving is artifacts. And unlike the knowledge, long-term knowledge and session and state, these artifacts are not pure text. We refer to artifacts as binary data that, like contents of files, and they are identified by a unique file name string. And you can save artifacts that are generated by an agent, and then load them again using another agent for further processing, or send them to the LLM for kind of questioning those artifacts. An artifact might be an image, might be a PDF file. And in a kind of, you see the pattern here is repeating. In-memory artifact service is to store temporary artifacts. So if you want to retrieve a PDF, send it to another agent, process it, and then you don't care about storing this permanently, then you can use an in-memory artifact service. It's also very good for prototyping. But if you want to save all these artifacts, especially like if it's a regulated industry and you want to be able to answer why an agent behaved in a very specific way, you need to have a way to store these artifacts and go and retrieve them if you want to investigate the agent. In that case, you can use a GCS artifact service, which stores, it's a persistent storage and stores these artifacts on Google Cloud Storage. Okay, so this is how you define an artifact. So you take the image bytes, for example, and then you create a part. This is, you find that in our Gemini SDK on creating this this type of an artifact based on the bytes, and you define the type, and you take that blob and basically you save it as an artifact. All right, and now let's talk about callbacks. So callbacks are the ability that you have to intercept different stages of the flow. You can have, and by the way, they're just 3 pairs of callbacks. So you have callbacks before and after you call an agent, right? So this is the very, like the, from the outside. Then you have a callback before you call a model and before you call a tool. And you have also kind of callbacks after you call a model and after you call a tool. These callbacks allows you to control aspects of the flow. You can intercept a call to an LLM if you don't think it's necessary, and have a custom reply to the user, which will have a demo later on. You can check before you call a model, what is the queries per second, and you can pause, or you can basically sleep and for a few seconds and then send the query to the LLM, so you don't let's say send too many requests per second to the LLM. You can have an agent after a callback after an agent gets a response to validate that the response doesn't have a PII information, for example, before you return that to the user. And therefore, with callbacks, you can also start adding guardrails into your flows. Right. Now let's jump to the basic implementation of the agent. And after this slide, you will see some code. I know we have a lot of slides, but for the next half an hour, we'll be going back and forth between slides and code. So hopefully this session will be quite more exciting. So here is how we define an agent. So you need to remember that with ADK, you have a base agent or the root agent, which is your entry point. And every time you trigger a workflow or you send something, it always goes through this main, let's say, gatekeeper agent that starts the interaction. And you might have just a single agent, which is the root agent, or you might have multiple agents that are kind of connected to that root agent. And we'll talk about how it's possible to make that connection. So we define the agent by giving it a model that the agent should use, the name, so this for the role play, and then an instruction. So what is this agent supposed to do? So let's jump into this notebook here. The first thing I do is installing Google ADK. This is essentially, downloading and installing ADK library into my environment. ADK gives you 2 different ways of using Gemini's model. The one is by using the developers API, and the second option is by using Gemini through Vertex AI. And this is what I do here. So I need to define 3 environment variables. The one is the project ID. The other one is the Google Cloud location. So where we're running this from, or where we want this to to run it from. And then is the fact that we want to use Vertex AI, right? And we set this to true. So very important to set these 3 environment variables, because ADK reads from your environment variables to do the authentication and get back results from Gemini. Because I'm using Colab here, I authenticate. Otherwise, if it was your local machine, you would have the gcloud command to authenticate. And what you see here is nothing to do with ADK. It's just me try to predefine the results from the agent, so it's easy to show you what the agent does and what it gets, the responses you get. So this is just I predefine the response and nothing else. So agents. We talk about an agent. I didn't talk about an application. I didn't talk about the user ID, and we briefly talked about session. But hopefully you will be able to understand all this in this example. So when we have an agent, but in order to run this agent, we want to plug it into what we call the application, and we use a runner to run this application. Therefore, we have an application name, and we have this user ID and session ID. I don't actually use session ID because I let ADK create this on the fly, but you can decide the exact session ID to use, or you can retrieve all sessions by using a session ID that already exists. Now, user ID is really important, and you cannot start a conversation with an agent without an application name and user ID. And why is that? Is because an application will have multiple users, and every user will have its unique ID, and every interaction with this agent will be based on that combination of user ID. And this is so that sessions and conversations between other users, they don't get mixed up. So they are isolated and saved into a separate session on its own. So we define here the root agent, as I showed you before. We put the model as Gemini. This is a teacher agent, and we describe the agent here. Agent that is good into answering user questions and helping with homework. Very generic. I didn't put too much thought in this. And then we say here, you're able to help the student with homework and provide answers. Basic formulas, don't hallucinate, don't answer questions that require external knowledge, don't generate code. And then what we say here is the output token. So these are some parameters you can pass for the model. You can restrict the output of this agent if you wish to do so. We define here the memory service, and that's an in-memory session service. And this is the runner. As I said, you pack your agent with an application and a session. And this creates kind of a runner that when you use this runner to ask a question, then it will be using the very specific session for a very specific user, which you see here. So we define the runner, and then we define the session using the application name and the user ID. And we create a text, which is hi, and we send that to the agent. So as a user input here. So we do runner.run, we pass the user ID, the session ID, and we pass the new message. And we get the response. So I say hi, the agent says, hi there, how can I help you with your homework today? And let me show you what happens in the session. So I get back the session here. I retrieve the session. So I want to get the updated session after that turn. And you can see a lot of useful information here. So this is the session ID that was created for me. So I can retrieve this session again, like especially if this was persistent, using this session ID. So I can resume conversations. I have the application name. I have the user ID. State, which doesn't have anything at the moment, and events. So the events are pretty cool to understand, like the flow of the conversation. So first of all, I have the user that says hi from user. So you can see here, the role is user, so it's me, and I said hi. Then I have another event, which is, let's find the response. This is the response from the model. How can I help you with your homework today? And some metadata there, if there was grounding, if the turn is complete. And I have here, let's search for events. Yeah, so it's basically these two events, right? And then, I can just print one event here so that you see how it looks like. Right, and then I can continue with the agent, like what is 2 + 2? Remember, this is a teaching assistant and is able to answer some basic questions. 2 + 2 is 4. I can ask, hey, what's the weather? What's 10 degrees Celsius in Fahrenheit? And the agent knows how to use basic formulas because we put that into the prompt, and is able to infer that this question is about finding out the weather. Is doing some reasoning here and decides that to convert 10 degrees to Fahrenheit, it needs to use the formula, and it yields 50, and therefore it's 15 degrees Fahrenheit. Right? But the calculations happened in a natural language format. So it didn't use a calculator, it didn't use Python to write the formula. And this can be, sometimes for complex questions, this can be a problem. And we'll see like an approach later on as a solution. And then I can ask, what is the weather in London today in Fahrenheit? I said this morning it's a very hot weather today. Let's find out. And oops, the agent cannot respond to that. So what we see here is the agent replying by saying, I cannot give you the current weather in London because I don't have access to external websites. So what do we do now? We look into tools. So a tool essentially is what allows the agent to connect to the outside world, as I explained earlier. And how it works is that the agent is processing a request, and then it sends our request to an LLM with the tool options, so the list of tools that it can use. Then the LLM will give you back the suggestion of what tool to use and with what arguments. And the framework now will execute the tool that the LLM suggested with the arguments that the LLM recommended. And after the code executes, we'll get the result. The agent framework will send the result of the tool, which might be a JSON of weather, and then the number. It will send it back to the LLM so that it can turn it into a natural language, and that will go back to the user. We have 3 types of tools. We have the built-in tools. So those are tools that ADK provides, like code creation and execution. You have third-party tools. I mentioned earlier that we can use tools from LangChain and CrewAI within ADK, so we can wrap those tools and reuse them. And you have function tools, which is building your own tools using Python functions. And this is how you can define a tool. So you can have a Python function which you you define, like, you give it a name and the arguments. You have to have doc strings that explain what this function does, and you have a logic inside that function. And the logic could be anything. So it doesn't have to be kind of programmatic, the way you have it there, by having exactly the city. You might call an API, and because it's Python code, you can do whatever you want. You can even call another LLM here. You can call APIs. You can, connect to databases and retrieve data, right? So you have freedom, and you can wrap your tool into as a function tool, but this wrapping is not necessary. The IDK is smart enough to identify that this is a function tool, and you can even use it as it is, get weather report. So then when you create your agent, you pass that tool so that the agent has a set of instructions and a set of tools to use. So let me demonstrate that. Before, when I asked about the weather in London, it said, I cannot help you. You're on your own because I cannot access this information. So let's make this agent smarter, right? Let's move from maybe an agent that wasn't necessary to be agent, because I could do these basic questions with an LLM and prompting, to something that is really agentic. So now I have 3 tools. The first one is a tool that, based on a city name, for example, London, it will give me the coordinates of London. It will give me the latitude and longitude. So using that, I can find the weather in that specific location, in that specific coordinate. It's really important to have these doc strings, because this is how the model knows how to use a tool. So don't you ever try to create a tool without this, because that will confuse the agent. The agent won't know what this tool does. So this is super important. We explained that this tool returns the coordinates of a specific city using latitude and longitude. We say that the city is an argument that is actually the city name in lowercase, and it returns a dictionary containing the latitude and longitude of a city. And we also give an example on how this tool can be used. You can call this this tool like this, pass the city, and that will give you back the coordinates. So then I have another tool, which is the weather tool, which will give you the weather based on latitude and longitude, and same kind of the same, let's say, approach applies here. I need a description. I explain the arguments. I explain what the response is, and I also have an example of a request and an example of a response, so that the model knows like what's expected to happen when we call this tool. And then I have a conversion, which I talked earlier about the LLM making the maths, which is not always a good idea. This is more deterministic. I let the agent know that there is a tool that can be used to convert Celsius in Fahrenheit. Right, so now I create this tool. So I define these 3 functions. And then I have the root agent, which is the teacher, good into answering questions. And I give this agent 3 tools, like the 3 tools we define there. And then I do the same. I create the runner, the session. This is something you saw before. And I say hi. And the agent says, hi, I'm here to help you with your homework. What are you working on? And that's just because that's what the agent, the prompt says, that it's an agent that helps with homework. And what I can ask is, what is the current weather like in London? Report the temperature in Fahrenheit. So let's have a look what happens when I ask this question. So the agent now knows that there is a tool called city coordinates, and the agent can use this tool with the parameter London to get back the coordinates. So it decides to use a tool. The function call returns these coordinates. Then it knows automatically to take these coordinates and send them to another tool called weather with these parameters. The weather tool will yield a long JSON that inside it includes the weather in Celsius. Sorry, the temperature in Celsius. And then it will take the Celsius, like extract from all this value, 23.6. I told you it's a very hot day today. It will extract this value and put it into the Celsius to Fahrenheit tool, right? And then we have this kind of Celsius converted into Fahrenheit, and it gets back this response, sends the response to the LLM, and get back to the current weather in London is 23.6 degrees Celsius, which is almost 75 degrees Fahrenheit. All right, so pretty cool, huh? And then we promised to talk about MCP. I don't have an implemented example today, just because of lack of time. Not sufficient time to go through in depth on MCP. But what you need to know is that MCP provides a standardized way for your AI models to access and interact with external tools, data, and other systems. And it makes those tools and resources reusable by other agents. So an MCP server standardizes this process and how the model can make use of a very specific context. And it stands for Model Context Protocol. So the model without context is just an LLM call without any knowledge, without any tools to use. And that's what context implies here. The context is tools like functions that the model can use, like query databases and update databases and APIs. Resources is also context. Let's say resources might be documents, like attachments and PDFs. It can be even prompts. So you can create or load prompts into your agent dynamically. It's not so commonly used, but it's also something you can use MCP for. And essentially it standardizes, like if you want your base agent to talk to the PayPal API, you need to implement the conversion of the tool to the API and build a tool for each API call. And this is this a lot of effort. Whereas PayPal provide now an MCP server, which the MCP server communicates with the PayPal API. So your only job is to point your agent. And by the way, the ADK has an MCP client built in, so it makes your life way easier. And that MCP client communicates with the MCP server, and the agent knows what we can use from PayPal and talk to that PayPal API through MCP, right? So it makes our life way easier. How do you define the MCP server to your agent? Well, it's a tool essentially. So you wrap it into an MCP toolset, and you put some parameters like the type of connection that you want with the MCP server, the command, and the arguments. So like what you see here is where, how, and what HTTP. The communication is over HTTP. So where the server is, and with that, we are able to connect to PayPal's MCP server. Now there is one more type of tool, which is the agent as tool, and this allows other agents to act as tools. And you have the user asking a question, which the question goes to the assistant agent. The assistant agent will take that question and ask another agent in the background. So this assistant is acting as the agent in the middle, as I call it. So the user always talks to the assistant. It will never talk directly to the weather agent, but the assistant itself can go and get information from other agents, get the response, and then give it back to the user. And this is how you define agent as tool. Basically, you take an existing agent and you wrap it around agent tool wrapper or object. And now we can have agents as tools. And this is very different from using sub-agents, because agent as tool, as I mentioned, the agent is always like the tool agent is always in the background. So you never interact with that agent. You always interact with the main agent, and the main agent is the agent in the middle. It will go to the tool agent, get information, and give it back to the user. Whereas when you use sub-agents, there is a type of transferring that is happening. So when I ask a question to the root agent and the root agent doesn't have the answer, it can transfer me to the other agent that can help me. So think of it as calling a call center and asking a question about, hey, like my car needs a service, and the operator says, hold on a minute, let me connect you to the service department. So they transfer me to the service department, and now I talk to a person, authorized person, to answer questions about my car service. So the whole conversation is transferred to another agent, and I can ask to be transferred back to the root agent, or I can instruct the weather agent at some point to go back and transfer to the previous agent. How we define sub-agents is by using this sub-agents variable on our agent, and we put kind of our agent there as a sub-agent. So very quick demo of that. So let's use an agent as a tool first. So we have the map agent here. So this is an agent that can answer questions about maps, like giving you the latitude and longitude of cities. And this map agent has the city coordinates tool, as kind of a tool that can use. Then the root agent has three tools. The weather tool, so the tool that gives you the weather on specific coordinates. The tool to transfer the weather in Fahrenheit, the Celsius in Fahrenheit. And an agentic tool, so the agent tool, that is the map agent. So let's now ask the same identical question we asked before. How's the weather like in London? Give me the temperature in Fahrenheit. The agent will call the maps agent with a natural language request. What is the latitude and longitude in London? So the difference is that it's not calling a tool with parameters, it's calling an agent with natural language. The agent says the latitude of London is 51 and longitude is minus 0.11. And now is calling the weather tool. And this is only the kind of the assistant agent is calling the weather tool, and then the Celsius to Fahrenheit tool, and then gets back the weather is 75 degrees Fahrenheit. Now let's use a sub agent. So in a similar way, I'm using the same agent, so the map agent, but now the map agent acts as a sub agent, so it's not a tool. So what we expect here, as I mentioned, is to have a transfer between the previous, like the root agent, the teacher agent, to the maps agent. So let's start chatting. So let's first ask, who are you? I'm an agent that is good into answering user question. Let's say, what's your name? My internal name is teacher. So now we are talking to teacher. So let's ask teacher about the weather in London and report in Fahrenheit. The teacher says, I cannot get the weather for you, but first I can get the weather, but I need the latitude and longitude. Would you like me to transfer you to the map agents to get the coordinates? I can say, yes, please. So now we expect a transfer to the maps agent. So now the agent says, hello, I'm maps agent specialized in map-related operations. I can help you with longitude and latitude. So I can say, yes, please, can you get me those? And fair enough, the map agent says, here are the latitude and longitude. Would you like me to transfer you back to the teacher agent to get the weather information? So now the job of the map agent is done, and it's asking if I want to be transferred back. I can say yes, transfer me back. So what I expect now is to go back to the teacher agent, who will take this information because it's stored into session, and then the teacher can say the current temperature in London is 75.2, right? So we've seen the whole kind of transfer interaction with sub-agents. And that takes us into workflows. So here we have the concept of a workflow. So what we've seen so far is using LLM-based agents, but I can use workflows to make a couple of agents behave in a very specific way. So sequential agent. What this allows me is to run one agent after the other in a very specific order. So call agent 1, and once agent 1 is done, call agent 2. I also have parallel agents. So I can call multiple agents at once, maybe because their tasks are not dependent on each other, or because I want to get several outputs. Let's say those are story writers, and I want to get 3 stories out of each one. So I run them in parallel, and then I compare the stories. Or I can have a loop agent. So a loop agent is, I run a sequence of agents in, again and again and again. And this is very helpful when, for example, I have an agent that writes specifications or user stories, another agent that generates code, another agent that generates tests, and the final agent that validates. And then it can go back and do the operation again, or correct, like give feedback, and then go back to the beginning and run this again and again until I refine my code and get the best result out of it. So let's have a look into these workflows very quickly here. And kind of a side note here is that ADK allows you to define schemas on how you expect the agents to respond. And basically this is forcing the agent to generate a JSON with these very specific fields. It's very important to describe the fields here, and this is used by a grammar checker agent, where it will correct a story if there is any grammar issues by providing the original, the corrected text, and explanation why this is a problem. So I define a writer which writes kids stories between 3 and 8-year-olds up to 500 words. And on purpose, I say make some grammatical errors so that I can demonstrate here how a grammar checker works. But in theory, you shouldn't have this here. And the grammar checker will check for any issues and provide suggestions. And what I do is I wrap these 2 agents into a sequential agent, right? So this is a sequential agent, and it has this is a story writer checker agent, which has these 2 sub-agents. Oh, sorry, I have a 3rd agent, which is a reviser. So after the feedback from the grammar checker, the reviser will take that feedback and correct the story based on that. So let's write a story about a boy called Mark and a dog that they go on an adventure. So the agent, the writer, writes a story, a very nice story about the boy called Mark and its dog. And what we have here is the grammar checker found an error. He almost ate one. We need to see that in the context. So it's corrected into almost ate one. And then the story here is, let's see, it's corrected by saying, like, the reviser rewrites the story by changing the error that the checker found. So this is how you can run a sequential agent. So now let's change that into a loop agent. So what I do here, I have 2 agents only. I have an agent that writes a story like before, and I have a critique. So the critique will provide feedback on this story. And the feedback will be to add more emotion, to add a character, to make sure that the story is kids friendly. And what I do, because this is a loop agent, I go from story to critique to story writer to critique, and I improve the story in multiple iterations, and I say do that up to 3 times. Of course, you can have an acceptance criteria or an exit criteria where if the critique says the story is good enough, you can just exit without going back to the beginning and like run the loops again. So running this here, we can see that let's see, we have a story that is going to be generated. The prompt is the same. The story is generated, then we expect the critique to provide some improvement points. Overall, ramp up the excitement, show, don't tell, add sensory details, and give some instructions and suggestions on how to improve the story. Now the writer will rewrite the story, and what we expect is to have, actually this is the first feedback, then we go down to the second feedback. Significant improvement, the story is much more engaging, but also look at a few more points. And the writer writes again, and then there's more feedback. And then we do that into like up to 3 iterations. So we've seen workflows and agents as tools and child agents or sub agents, as we call it. And this is how you can create multi-agent systems. You've seen basically how, hopefully this is very helpful on how to get started with this. I talk about callbacks, so I want to have very last kind of demo here about callbacks. So callbacks is how we intercept the flow, and we said we have before and after agents, before and after tools, and before and after the model, the LLM model call. So here I define a before agent callback, and what I do is I say if there is a state variable that the user level is basic, say that is unable to process, the agent shouldn't engage. So imagine that this is an agent that only engages if the user pays premium to my service, right? I just made this up. So, and then I start kind of with a state saying the user is basic. And I say, basic. And I say, what is 2 plus 2? So what you see here is that we jump into the callback and says agent teacher with stage that. So we are inside the agent callback, and we customize the response. We say the agent is unable to process this request. Please update to advanced level. So, and again, so we intercept the request to the agent with a custom response here. Yeah. And let's say now the user updates their subscription to advance, and we run it again. And we can finally get a response, say 2 plus 2 is 4. Yeah, so just like that. So this is essentially how you can use the callbacks. So I want to very quickly, and conscious of time, show you ADK Web and evaluations. So ADK Web is a built-in tool to ADK that allows you, it gives you a web interface and allows you to interact with the agents you build. And it helps you with evaluation and tracing. And it's a web developer UI that will eventually make your life much easier. So without kind of talking too much, I want to show you here. So this is ADK Web. The way you run it, you run on when you install ADK library on your computer or on the machine you're running this from, you can run ADK Web, which will start a service, and you can select your agent here because you run ADK Web from the location where the agent is inside. and then you can start interacting with your agent. I can say hi, and then the agent knows, because of the state that I'm Alex, and say hi, Alex, and so on. And that helps you debug by saying what is in my basket. And you can see here that is accessing card information, getting back a response, and you can see all this back and forth here on this side panel, and then you get the response. I can go, these are the events that are created from like my question to getting back the final response. So I can see all the events here, the requests, the responses. I can even see tracing. So I can see for this request, there was the customer service agent was called. It called an LLM. It executed tool, and it called an LLM again to hydrate the response of the tool to natural language and then back to the user. And I can also run evaluation. So I might want to save this conversation as an evaluation set. So what I do is I can say add current session to my evaluation, and I can select that and run it. And the nice thing about is every time you run evaluations, they are time-stamped. So this is passing. So what this what this pass means is essentially like that rerunning these prompts will use the tools we expect it to use and provide a response we expect it to provide. There are some settings you can set for your evaluation criteria, but the power of this is that you can write long conversations, save them as evaluation sets, and then run these evaluations again and again to make sure that your agent performs in a consistent way, right? And you get all that out of the box using ADK. Right, so let's talk about deployments. So when you build your agent, you have different options to deploy the agent you created using ADK. You can use Vertex AI Agent Engine, which is our fully managed service to deploy agents. And it's not just ADK agents. We support other agents as well. You can deploy your ADK agent, though, with a single line of code. You can, because ADK is open source, you can wrap it, on a Docker file and deploy it on Cloud Run. But we also provide a kind of a shortcut way to do that by doing ADK and deploy Cloud Run. So that will deploy the agent on Cloud Run as a service. So you can use your agent through an API, and then you can even deploy on GKE or custom infrastructure. So you have all the freedom there. How do you deploy the agent? So you create your agent as I showed you so far. Then we have a reasoning engine here definition, and then we do agent engines.create. We pass the agent and some libraries that our agent depends on, some requirements. So this is the minimum that we need ADK, but your agent might use pandas. We need to add this requirement there, so it gets installed where the agent is deployed. I talk about evaluation, so I'll jump into a world of agents. So we build agents, other people build agents, and you have all these kind of agents that they pop up and being available by different organizations. And these agents, you don't always have controls of these agents, but they might be very useful to use inside your own agentic system. And this is where A2A comes in place. So it's an open protocol to handle agentic collaboration. It's a protocol developed by Google, and it's adopted by other kind of large organizations that are contributing and supporting into A2A. And the idea here is that your agent is now able, using A2A, is able to talk over standard protocols with other agents. So imagine that you have a PayPal agent now, which my agent is able to talk to and exchange information and give some tasks and operations. And these standardize this collaboration and connection, so that your agents now can be reusable. ADK provides a native support for A2A as it does for MCP as well. So to recap, we talk about agents and multi-agent architectures. We talk about when you do need and when you don't need to use an agent. And we spend a lot of time explaining how you can use agents with, how you can build agents with ADK and what advantages ADK provides. We talk about evaluation and deployment of these agents, and we kind of briefly chat about why A2A is a big thing when we move into this agentic era that we find ourselves to. And with that, back to Timon.
Yes, I'm here. I'm back. And thank you, Christos. Please take a moment, have a glass of water, take a stretch before we come back to the Q&A. Thank you so much for recapping and also for providing such an informative session to us today. The chat was busy. The Q&A section was busy. We're doing our best to answer all of this, but we're going to get to the Q&A very soon. We have a couple of questions round up, so let's see how it goes. But before we do that, as I call it sometimes, a commercial break. It's not a commercial because it's something for you. There has been 2 or 3 questions around that. So everything that you're learning here, all the agents, everything related to Google technologies, please do remember that we have this Google for Startups Cloud program. This is our way to help startups that are starting up to ease the costs associated when you're building prototyping. So we have this program that allows you to get access to workshops, to experts, but mostly to Google Cloud Platform credits that can be also used for Gemini, not for the models that are in Model Garden that are not Google models. But when you're starting, you get $2,000. When you have a VC fund, you can get $100,000, $250,000. So if you're really a builder of a startup and you have something in mind, you have a prototype, you have a running product, please check the cloud program. This is our way to help you startups grow and to help to build your GenAI solutions with us. This is a great entry point to Google. You will get your startup success manager. You'll become a part of a bigger community. So that's something worth checking. So Google-Cloud-program and the QR code over there as well. With that, again, this is something that you've seen already, but for those that are new, just a few moments to scan the agent handbook, great hacks to use your AA agents for business. So something worth checking and downloading as well. And of course, so that the discussion can continue, we do have our Discord, Google Developer Community. There is a specific channel for Startup School and agentic and generative AI topics. Please do, if you're a Discord user, sign up and join the community. We have some discussions over there. We have some Googlers over there. So I think this is worth checking. With that, before we go to the Q&A, I'd love to ask you for the feedback. This is the only thing that we can get back from you, and this is very important for us to understand how you like these sessions. What can we do better? Or maybe we nailed it. So share your thoughts about this week 2, Google/agentic-W2, or the QR code, obviously. Please select which sessions you were attending. So it was APAC friendly or Americas friendly, because EMEA can join both, and let us know. It's also a token of gratitude to our speakers to let them know how they did. So if I really can ask you to bring your Google Pixels or whatever you're using and scan a QR code or type that in your browser, I would really, really, really appreciate that. This is an important part of our job to get the feedback and understand how we did. Okay, with that, we get like 5 minutes for me and Christos to talk a little bit. So Christos, I hope you're rested and you're ready to go, because I have some questions to you. Alrighty. So I think this is the part where you were mentioning when not to use an agent, but just to recap this part. So Meltem is saying that an agent development kit seems like a comprehensive solution, but their case is a simple scenario. Probably need a single agent with some RAG versus tools. So is it an overkill to use ADK, especially in terms of learning curve? Does it make sense to start with LangChain and then if they need to migrate to ADK? So what's the ratio when you should think about ADK and when a simple RAG and LangChain should be enough?
Yeah, this is a very good question. I think ADK, because if you remember the stack I showed, level 0, level 1, 2, 3, 4, and 5, ADK sits on level 4. You mentioned learning curve, but I think you can build what you're like a simple agent with RAG with no more than 100 lines of code, even less. So it is very simple to use, and I think this is what I love about ADK. Is I work a lot with customers creating POC. I jump into ADK and then like half a day and I have a POC ready to show. So I would say take a stab on using ADK and see how you find it. However, like on a very simple RAG use case, like I said, like, do you even need to use an agent? Because agents do thinking, and if it's a very simple RAG, if you don't need the thinking, then
it's retrieval, no thinking, exactly.
Yeah, and then it's latency. Like, how fast do you care about the response? Like, can I wait 2 seconds, 3 seconds? Do I want a response below 1 second? So there are other things that come into play. But learning curve, give it a go, and then let's talk again, because I'm sure you'll be surprised how simple it is to build these agents.
Great. When it comes to the thinking, there is another question coming from Tim. Just on this meta level, so if the agent decides which tools to call, how do you evaluate the quality of the decision that agent has made? For example, in a critical process where calling the wrong tool as the next step could break the system, hallucinations can become a serious issue. Or for instance, if the agent is following a goal, choosing the wrong term could throw it off course. That's true. Like, we are not seeing, like, we can see the reasoning and the thinking and we can analyze what they are doing, but in general, how we evaluate the quality of the decision and how we make sure that in critical processes it does not using the wrong tools.
I'm sure this question came before I showed evaluation. So evaluation process that I showed, which there is this UI of building evaluation, but you can also add your evaluations using PyTest if you're developing inside your code and you run them every time you do a change. That evaluation does 2 things. It checks the tool trajectory. So if the tools that are used are the tools you expect the agent to use at the right part or spot of the conversation. And the other is if the agent is replying in a way you expect it to reply. So these 2 things together, you check like the tool trajectory and if the tools are used correctly. But you also have callbacks. So inside callbacks, when the tool is triggered, you can check and say, don't go or don't use this tool if that previous tool was not called yet. So if you want a tool to be called before another, you can have in the before tool callbacks or before agent callbacks this logic to say, hey, did you first bring data before you try to analyze data? If not, go and do that first. And we can add these guardrails using the callbacks, but evaluation callbacks together can do miracles.
The last one, a short one, and again from Tim. Tim is a good person at asking question. So can we freely define the metadata for an event? For example, using metadata tags specific to a use case like generating an image, or are the metadata tags predefined within agent development kit?
So the metadata you have there are predefined, but you can create more events yourself, and you can start saving information into state. So you can create state variables that they hold additional key value information, and you can create state information as part of an event, so it goes in the right chronological order when this state value was created. So there are 2 different ways to create a state. You can just change the state, which you won't know when that state changed because you don't see it in the list of events, or you can create a specific event for this change of state.
Okay, super last one, because I promised to Araf on the chat that I'll try to ask this, and we're almost at time. So would it be possible to use Fire-based storage? And so Firestore real-time databases for persistent storage of message logs from user agent through the agent ADK. So the topic of memory and using Firestore in real-time databases, persistent storage.
Yeah, so that's a very good question. So here is what I know, right? We don't have a connection to Firebase as of now. I don't think. I need to have a closer look. I don't know if that is something in the roadmap, but ADK is open source. We forgot to say that. Yeah, it's open source. So I challenge all of you to go and build functionality for ADK. You can go and build a connector to Firebase. You can go and add embedded tools into ADK, and we expect that this community of people that they collaborate and contribute to ADK will make this better going forward, having more connections.
Okay, Christos, thank you so much. Please do now enjoy the sunny weather. We know how the weather is like in London right now. We had an agent for that, and a few people on chat confirmed. So thank you very much for your time today and sharing your expertise and knowledge. And to all of you that were with us today, thank you so much for joining Startup School Agentic AI. Today we are wrapping up, but this is not over. There is a next Startup School Agentic AI session coming up next week. So as usual, we meet on Tuesday, but the next week is going to be special because we're going to have Tuesday, Wednesday, and Thursday. So on Wednesday, we're going to have a guest speakers from Datadog. You cannot miss it. But first, we meet on Tuesday. We're going to build hands-on solutions with the first agent with ADK. Pier Paolo Ippolito, our field solution architect, will join us live on Tuesday, June 24th. It's just in the 5 days. So please take time to practice something in labs and notebooks, and see you next Tuesday. Thank you.